Welcome to the site, Oche. Think of chemistry as the ultimate construction project. If you build without checking the foundation, the structure collapses under pressure. Today, we lay the groundwork. We are opening the blueprint for JAMB Objective 1AB, distinguishing elements, compounds, and mixtures, and differentiating physical from chemical changes. I am Prof. Chemi. I have spent 20 years in the lab reviewing these exact blueprints. If you want that 90+ score, I expect sharp attention. Look at how the board structures its questions. They often present a simple physical mixture in a way that suggests a chemical reaction has taken place, hoping a student will confuse a collection of parts for a single structure. To navigate this, we use the molecular masonry protocol. This is a framework for determining if a substance is a loose pile of materials or a cemented, load-bearing structure. Passing this section requires looking past the surface appearance of matter and identifying its actual structural integrity. If you can see the bond, you can avoid the trap. Let's get to work. We start with the elements. These are the single bricks of our construction site. You cannot break an element down into a simpler substance. It is the absolute base material. The site gets active when we introduce extreme heat or energy to these bricks. Instead of remaining separate, these bricks fuse into a single unit. That locked structure is a compound. When iron girders and oxygen react to form iron 3 oxide, or rust, they are permanently joined by a chemical bond. That bond acts as molecular cement. Once elements form a compound, they lose their individual properties. Iron is magnetic and oxygen is a gas, but rust is neither. The wall has properties entirely distinct from the bricks that built it. Because this molecular cement is a physical reality, you cannot break it with a mechanical push. Tearing a compound back down to its elements requires chemical demolition, like intense heat or electrolysis. Any process that creates or breaks this cement is a chemical change. The fundamental architecture of the matter has changed into a new substance. Now contrast that cemented wall with a wheelbarrow full of loose sand and iron nails. That is a mixture. There is no molecular cement holding them together. Applying our builder's logic, because there are no chemical bonds, every substance in that mixture keeps its exact original properties. We use those original properties to clean the site. A magnet easily separates the magnetic iron from the sulfur powder. No chemical reaction is required. This logic scales up. Whether working in a tiny lab beaker or a massive industrial distillation tower, a mixture is separated through physical means. Let's map this out. A mixture has no chemical bonds. It remains loose. A compound is chemically bound. In mixtures, properties are retained, and separation is physical. A compound requires chemical separation and follows a fixed formula. Therefore, a physical change is merely the sorting or mixing of materials. You are rearranging the site without pouring or breaking the chemical cement. Oche, pay close attention. The board often tests you on homogeneous mixtures, substances like salt dissolved in water that look perfectly uniform to the naked eye. Here is a foundation check. If we stir table salt into water until it disappears, have we created a new compound or just hidden the bricks? The salt is just hiding. No molecular cement was poured. On a microscopic level, the salt particles sit side by side with the water particles, but they do not fuse. We prove this by using physical separation. Boiling the water evaporates the liquid, leaving the original white salt crystals behind in the beaker. This means phase changes, such as melting or boiling, and the act of dissolving are strictly physical changes. The core molecular structure remains intact. Let's run a final inspection using a question from the 2014 UTME. We will apply our construction logic to see which option holds up. Option A claims the properties of a compound are those of its individual constituents. We know a cemented wall doesn't behave like loose dust, meaning option A fails the inspection. Now look at options B and D. A mixture is always homogeneous, and a mixture can be represented by a chemical formula. A pile of rubble is still a mixture even if the pieces are different sizes, and random rubble follows no strict mathematical formula. Both options are incorrect. This leaves option C. The constituents of a compound are chemically bound together, while those of a mixture are not. This correctly identifies the presence of molecular cement. The foundation is set, Oche. To ensure your understanding is structurally sound, go to the studio and launch the 1AB video, slide, and mastery quiz.
Return to the dashboard and take the Mastery quiz to move your chemistry progress bar to 100%. We are building a master chemist here.